Back for part two. Okay, so now we're going to talk about the graphs, and the first graph we're going to discuss is the histogram, the frequency histogram. And a histogram is a special bar graph, not just any bar graph. Um, it is a special bar graph, and it talks about the frequency distribution that we just found a minute ago. The scale on the bottom, the horizontal scale, is always numbers, and it measures the the classes that we had, and the vertical scale measures how often something happened in that group, and they must touch. There's no space between the bars. That is very important to notice, and it's very important to do, which is why we're going to talk about that. So if there was a space, like from one group was 0 to 5, and the next group was 6 to 10. If we go to graph that, then we're going to have a space between 5 and 6. We don't want any spaces. So because we don't want spaces, we have to do a little bit of fancy footwork and make some class boundaries. And what I call it is a cushion. So where there was space, we're gonna expand those class limits into wider boundaries so that there's no space. And this is what it says. It says because they have to not touch, then we have to use boundaries instead of class limits. And the numbers that separate the classes without forming gaps between them. So here's the big old table that we had a minute ago, but now we're adding, so we already talked about class midpoints, relative frequency, and cumulative frequency. Well, now we need to add in there class boundary. So I'm going to ignore that middle row. I only need the limits, the frequency, and the boundaries for this. So first we're going to find the class limits. We're going to look at those. We already have those. We found them a minute ago. Then find the frequencies, which we used a tally mark chart to help us find that a minute ago. Then to find the class boundaries, we take each of these lower limits and we back it up or subtract 0.5. And we take each of the upper limits and we bump it up or add 0.5. So we're going to take 155 minus a half, and we get 154 and a half. And we're going to take 190 plus a half, and we get 190.5. Then we do that with each one of these classes. So we'll do that with 191. We'll bump it down. It'll be 190.5. And this 226, we'll bump it up. It'll be 226.5. So this isn't a difficult thing. You just have to be careful, and it is detail oriented, but it is pretty easy to do, especially when I show you a couple tricks later on a spreadsheet, how to do this a little bit faster on a Google spreadsheet or an Excel spreadsheet. Makes it pretty quick. Then to finish off the histogram, we're going to use, there's two ways that you could do this. You're going to do a bar graph, and the bottom, you could mark those from, you could use the class boundaries. These boundaries right here, you could use those to mark those little spots, right? 154.5, 190.5, 226.5, 262.5. So you could use each of those, and then you just figure out, okay, so in this class, there were 3, so I make my bar go up to 3. In this class, there were 2, so I make my bar go up to 2. That's one way to do it. Or, and that's got a blue outline here because it's about boundaries, or we could use the midpoints if we wanted to. If we use the midpoints, it would look a little bit like this. And instead of having the numbers on the edges of the class, we would have them in the middle of the bar, and we would use those midpoints then. So 172.5 goes up to 3, 208.5 goes up to 2, etc. Now, one thing I want to make sure I talk to you about is this little squiggle. That is a math nerd or statistics nerd way to show that the distance from 0 to here is not really that small. We're basically saying, okay, 0 is way out here. I didn't feel like drawing all this space blank, so I just squished it down, and you use this little symbol to show that it is a broken axis. Basically, we squished it, and there's space in there that we're not drawing to scale. So when you do a histogram, you could do it two ways. You could either do it from the boundaries or the midpoints. And let's look at what it would look like for the boundaries again. It looks the same, except this bottom part, the numbers are a little different because they're using a different set of numbers to come up with those, okay? Either way is awesome. Just be careful to do it if it's in an assignment. Be careful to do it the way they ask. If they don't ask specifically, you get to pick. So far we have talked about, in the last video and this one, we have talked about frequency distribution chart and a histogram. Now we're going to talk about a bunch of more graphs, a frequency polygon, a relative frequency histogram, a cumulative frequency graph, otherwise known as an ogive, not pronounced ogive. And they all use the same information that we already did to make our frequency distribution chart, that table that we already made. All the information is already in there. And the information that we're going to be using, that same info, is going to be class limits, frequency, midpoints, relative frequency, and cumulative frequency. Okay, and remember, limits is how wide each group is. Frequency is how often something happens in that group. Midpoint is the middle. Relative frequency is when you take that, how often it happens, and divide it by how many answers you got. And cumulative is when you have an answer, a frequency, and then you add it up with the next one, you add it up with the next one, and you just show how it's growing as you go along. Some more graphs, number one. So frequency polygon. On a frequency polygon, that is a cute little thing that's basically the histogram in disguise. Instead of using bars, they use dots and lines, and they make sure that on the ends, it goes all the way down to the horizontal axis at 0. So there's really not a ton different you have to do, except for adding those extra endpoints. So you draw a frequency polygon. The question says, example, draw a frequency polygon and describe any patterns. Basically, you look at what you already did, all the information you already gathered, but instead of it being a bar and stopping at 172.5, you need to extend those midpoints, and you do have to use the midpoint. You extend those midpoints out one more class each. So our class width was 36. So I'm going to go left, meaning subtract, 36 from this 172.5, and I'm going to go right, meaning add 36 to this 388.5. And that's going to give me my new midpoints that I need to include on here. I'm trying to get my face out of the way. So it looks the same, except instead of bars, we've got those dots. And let's actually go ahead and compare the two. Let me put those side by side for you to compare them. So on the histogram, we have bars, no space between them, and the bottom is the midpoints and goes up to the frequency. The frequency polygon, the bottom axis is still about the midpoints, but you add an extra one on either end. And the dots go up to the frequency, and instead of a bar at those dots, you then just connect lines. You do connect the dots. And so basically a frequency polygon is almost the exact same as a histogram, except bars instead of lines. So the next new graph, relative frequency histogram, relative frequency histogram. It's another histogram, but instead of using the regular frequency column in your chart, you use the relative. So I put this chart back in here again, except I blocked out everything that we're not going to use this time. We're just going to use the class boundaries and the relative frequency, the percent of the whole that we're talking about. And so the graph doesn't look a ton different, except you'll notice on the left side, instead of it saying 3, 6, 7, etc., it has percents or decimals that represent percents. So this 0.05 is basically 5%. This 0.10 is 10%. All the way up to the highest percent that works on here, and it only goes up to 23%. So this chart goes up to 25, but just the bar doesn't reach that high. So a frequency histogram, the bottom's all the same, the shape will look almost identical, and the left vertical axis will look a little bit different compared to a regular histogram. Next graph, ogive. Again, ogive, not ogive, okay? So this time we're going to use the cumulative frequencies. Cumulative frequency column in our chart that we already made. So we still use our class boundaries all the way up. And this time, instead of it going from, 0.05 up to 0.25, because that was the relative frequency, this one's going to go, the smallest, we're going to make sure covers 3, and the highest we're going to make sure covers 30. And we're just going to plot those dots. So at 406.5 right here, we're going to make sure it goes up to 30. At 370.5, we make sure it goes up to 27. That's it. Same info, new graph using a different column in our original chart. So that's all the information from 2.1, which is a lot of information. So you need to know what I want you to do now, right? So what's the plan, Flan? So we started project part 1 last week, where you asked your question and you got 50 answers. Project part 2 is going to be due this Friday because it's the end of the quarter. This is going to be your last official grade for this quarter. And you're going to create a Google slideshow for your project, where you have, we're going to add to it later. So, part 1, we got the information. Part 2, we're starting to build our presentation. And you're going to have one slide with your question that you asked people, one slide with your data, one slide with your frequency chart about your data. And I will make another video to give you some more tips on that. And then you're going to turn it in on Schoology, and you must submit this on Schoology. Do not email it to me. Make sure I can open it, but you must submit it on Schoology. Again, that's due this Friday, and it is the last grade of the first quarter. I also have on there a Math Excel for you to work on, and it'll take about an hour to complete. Okay, so that is due on Sunday, and that, because I won't have time to grade it fast enough. The end of the quarter is this Friday. That's going to be your first grade of second quarter. Okay, that Math Excel homework, it's still due on 12/18 this Sunday, but that's going to be your first grade of the second quarter. Okay? Lots of information. Remember, you can always go back, hit pause, rewind, rewatch. That's the point of the video. And I will put this PowerPoint slide on Schoology for you too. Okay? All right, you can do it.